Jake is here. Oh my gosh. Oh my gosh, the wizard is here.
Where is Jake?
Is that Jake?
Yeah.
I'm here. Oh my God. We'll wait till everybody crowds around. Is that Miss Hardware Science herself?
Yep. It's us.
Well, I'm glad to be here. Can you all hear me?
Yep. Can you guys hear me?
Sweet. I'm Jake. I'm Wizard 4. I've been doing this for, I don't know. I've been Wizard for a third of a century. Of course, there have been 4 wizards on the planet Earth in the last 200 years. And I'm number 4. And Melanie and Lisa asked me to stop by and show you some neat science activities, but I've got to see who's here. Is there somebody here named, how do you say it, Eureka? Is that how you say that? Do we have a Eureka?
Is she here? She was here earlier. She's not here anymore.
Well, she's not here anymore?
Yeah, she's here.
Oh, she's here.
She's here.
She's here. There's Eureka. Hey, I wrote your name on a piece of paper, and oh my gosh. How about Gnome? Is Gnome around? I'm taking attendance here. Gnome? There's Gnome. I see Gnome's name. Hey, there we go. Who is this person? Bradley? Do we have a Bradley?
Bradley's not here today, but you can still burn his name.
Okay, I'll burn Bradley anyway. There you go. That's what I think of him. All right, do we have somebody named Snoodle-Loop? Do we have a Snoodle-Loop? No Snoodle-Loop? Okay, we'll throw Snoodle-Loop over there. I don't know who Snoodle-Loop is. Lucette.
Oh, is there a Lucette? Where's Lucette?
There she is. Hello, Lucette from the Wizard. Okay. How about, is there an Ian with an N on it? There he is, right down there. There's Ian. Hey, that went towards me. Whoa. Stay away, Ian. Oh, here's another person. Dweezil. Do we have a Dweezil? No Dweezil? Gosh darn. Oh, we have another Ian. I can't believe we've got 2 Ians. Do I see another Ian? I just got to get to know everybody. I see 1 Ian. Oh, there's another Ian. Okay, we've got 2 Ians. And James. Do we have a James?
Where's James?
Oh, there he is, right there. James with a nice smile. I'll burn yours nice and slow. Nice, slow James burn there. Oh, that's fast.
Oh.
And Keegan.
Keegan's here? Keegan looking?
Right there. I see the top of their head. Keegan head. I see Keegan head. And this person must be big. A Fooznaddle Wizzy Bit. Do we have a Fooznazzle Wizzy Bit?
Who's not a wit now? No.
No Fooznazzle? Well, forget them. We're getting down to last. I hope there's a Dylan. Do we have a Dylan?
Yeah, I'm right here.
Hey, Dylan. How you doing, man? There you go. Up in flames. Whoop, you're gone.
Oh, there you go.
And the last one is Logan.
Logan? Logan here today? I don't know Logan today. But you can burn him too.
Should we burn Logan?
Yeah.
Yeah, say goodbye, Logan. Yeah, okay. Hey, I tell you what we're going to do. I want you to think like a scientist. Everybody grab your beard and go, huh? Everybody grab your beard and go, huh? I'm going to learn to think like a scientist from the old Wizard. I've been doing this since 1964, but the Wizards have been around since the year 1795. And this science activity was done in the year 1795 at the Royal Institution in London. And it's a neat activity. Now, I need, and I want you to do these activities at home. So go around your house and see if you can find something that's smooth and round. And it could be a spoon or a football helmet or anything smooth like this. Doesn't matter what it is. And then I want you to find a piece of wood. That's right, I don't need that. That's all right. This is a yardstick. But you could get a great big piece of wood if you wanted to, or a small piece of wood. And I'm just going to balance it on that smooth surface. Ooh, there it is. There it is. I've got it balanced. Yeah, right there. So Dylan, do you think you could do that? Yeah, you could do that.
I think I could, but because I do normally I can balance a pencil on top of a pen.
Oh yeah, you could use a pencil. You don't have to use a big stick. You could use a little stick if you want to. I just do this, and it kind of moves easy. Now I'm going to try to get that stick to move without touching it. It's a science magic trick. I'm going to get that stick to move, and I'm not going to touch it, and I'm not going to blow on it. I am going to use a balloon. Found an old balloon. And I'm going to rub this balloon on my shirt, or you could rub it on a towel or something like that. Or if you have a cat, do you have a cat or a dog around the house? Works better if you rub it on your cat. Woo! And what I'm doing is, or your baby brother's head or something like that, something that's furry, or maybe your dad's beard. And I'm putting a static electricity charge on the balloon. I'm taking electrons off of the fur and putting them on the balloon when I do that. And then all I have to do is take the balloon and bring it close to the stick, but not touch it. Here we go. Ooh, look at it move. Oh, I'm not touching that. I'm not touching it. Ooh. Oh my gosh. Think of the stories I could make up about this. This is a magic stick. Oh, speak to me, magic stick. Who is the best looking wizard in the room? Oh, I don't know. Yeah, oh my gosh. It's pointing right at me. It's pointing at me. No. Yeah. Who has the best looking nose? That must be Dylan. Dylan, you got the best looking nose. It's pointing right at you. I'm telling you. Do you think you can make this trick at home? Nod your head up and down. Yes, I could do that science trick at home. Let's go do another one. I want to try another one. Let's go to another part of the studio. Let's go over here. Oh, by the way, welcome to Faraday Studio. Have you guys looked around here? This is the neatest place in the world. We've got about 20,000 science activities that we share with people around the world. About 20,000 of them. You kind of look around, there's a lot of stuff here. And here's one you can do at home. Are these jars all charged up, Jacob?
Yes, they are.
Oh, cool.
Mason jars.
Okay. So, there we go. To do this activity, and it's kind of fun when it's a magic trick to do. I like doing this one at birthdays. It uses a little bit of science. I've got some baking soda and some vinegar, and I know you've probably done this many times, pouring vinegar on baking soda. Kind of makes a fizz. So that's baking soda. Got that at the grocery store. And use it to make bread and biscuits and stuff like that. And I've got some vinegar. Vinegar. V-I-N-E-G-A-R. Vinegar. It's really good smelling stuff. Ooh, that stinks. Smells like old rotten pickles. I guess it's used to make pickles. Melanie, do they have vinegar in Hawaii?
Of course they do.
Well, I didn't know.
Just like that. We have vinegars too.
Yeah, vinegar and vinegar. My golly. So I'm going to pour a little vinegar on top of the baking soda, and there's going to be a chemical reaction. So I'll pour it on there. Oh, look at that go. That's bubbling. You're zooming in on that. Look at all those bubbles. That's called effervescing, by the way. Effervescence, if you want to use a scientific name. And when I pour the vinegar in there, vinegar's got some acid in it, weak acid, acetic acid. It reacts with the sodium bicarbonate, or the baking soda. And the chemical reaction gives off a gas. It's called carbon dioxide. Now, you can't see it, but floating right on top of that vinegar now, there used to be air. Now, there's carbon dioxide gas. And you say, Jake, I don't believe you. I don't see nothing. There's nothing there. It's just air. Oh, it's special. Let me show you. I'm going to light a match. Oh, by the way, since I'm going to be working with matches, everybody raise your hand and repeat after me. Say, Dear Jake,
Dear Jake,
I promise and vow
I promise and vow
I will not do this activity at home
I will not do this activity at home
without my parents' permission.
without my parents' permission.
And if I become a low-down, sneaky weasel
I become a little sneaky weasel
and do these anyway
and do these anyway
without my parents' permission,
without my parents' permission.
Jake, you can come over to my house
Jake, you can come over to my house
late at night,
late at night,
sneak in,
sneak in,
and sit on my head.
and sit on my
And that's just what I'll do, too. Because you don't want to do this without having your parents' permission. Okay, so now I've got a match, and I've got a jar filled with carbon dioxide, a heavy gas that came from that reaction. Now, I want you to watch the match. I got it lit. Here we go. And I'm going to stick the match into the carbon dioxide. Hup. Did you see that? It just went out. I didn't do it. I didn't do anything. Let me do that again. That gas, that carbon dioxide, will not let that match burn. Look, oh, it started to go out. I'll go back down in there. No, it started to go out again. I'll go back down in there. Go back down there. Yeah, put it out. Well, there's two things I just saw. That carbon dioxide will put out a match. It won't burn in there. But also that gas is heavier than air. It's staying down inside here. Which is really kind of cool because you can take a jar like this one right here. It's an empty jar. Yeah, by the way, is this an empty jar? Hey, Dylan, is this an empty jar? Dylan?
It looks empty.
Good answer. But there is something in the jar. Do you know what's in there? Anybody?
Either carbon dioxide or air again.
Air. Yeah, there's air in this right now. But I'm going to, God, this man good. You're good, Dylan.
Keegan says air as well.
Oh, Ian did too?
Keegan.
Keegan said air. Yeah, the jar is filled with air. Well, what I'm going to do is take the carbon dioxide and I'm just going to pour it in there and fill that jar up with carbon dioxide gas. I'm just going to pour it in there. I'm going to pour that thing and fill it with carbon dioxide. And that's going to push all the air out. I'm not going to put any of the water in there or vinegar, just the gas. I'll cover that up. And I'll put the lid back on it.
Hey Jay,
Yeah.
he had asked me if it's similar to argon because they both cannot burn.
Is it similar to what?
Argon.
Argon?
Yeah, it's similar to argon because things won't burn without oxygen. You need oxygen for things to burn. So, yeah, this is similar. Well, argon is an element, and this is a chemical compound, but they are both gases, and they're both invisible to our eyes. We can't see them. Now I've got a jar of carbon dioxide, and I can set this up on the shelf in my house and save it for years. And I like to do that. I'll get jars of carbon dioxide gas. I've got a bunch of them right here filled with carbon dioxide gas. You say, what are you doing with that? Why would you have some carbon dioxide gas? Well, this is what's fun. Next time you have a birthday party and you put a bunch of birthday cake, candles on a birthday cake, you know, the normal way to put out the candles on the birthday cake is just to blow them out. Well, I got to do better than that. I'm a wizard. I've got to do something besides just blowing on it. Especially, I guess, during this COVID time, you don't want to be spitting on somebody else's birthday cake. Would there be a safe way to put that out? Well, all I have to do is get a jar of carbon dioxide. And instead of blowing those candles out, I'm just going to pour some CO2 on top. You watch the candles. Ready? 1, 2, 3. Sweet. I heard everybody go, ah. Wait, I didn't hear anything. Okay, never mind. But you do that. Make yourself some jars of carbon dioxide. You can keep them. And then next time you have a candle lit or something like that, just pour it out like that. Okay, let's do another activity at home. This is a good one. I've got a pan of water. Now you could do this in a bathtub or in a kitchen sink or do it someplace where the water is very quiet. I don't think you could do it in the ocean because it's moving around too much. But this is just very still water. And you'll notice that I took some pieces of paper and I cut out some boats. I call them boats. Look at that shape. It kind of looks like a boat, like a little motorboat, little rowboat. And I've got a little point on it, and then I cut a little round hole on a little slit. Kind of looks like a keyhole right there. And I'm going to see if I can get one of these to float in the water. Here we go. Hey, there it is. It's floating in the water. And the reason it's floating is that water has a surface tension, a skin on it, where the water molecules pull on each other, and they kind of make a skin. But I'd like to get this boat to move. Come on, come on, come on, come on, come on. Let's go, let's go. Oh, this is a dud. Oh, I got to put a motor in it. I forgot. I got to put a motor in there. Now, see, what could I use for a motor? Oh, I know what I could use to make this thing go forward. I've got some dishwashing soap. Yeah, a little jar of dishwashing soap. Yeah, I've got a little jar of dishwashing soap. Right there it is. And here's my motorboat. So you get some still water, cut out some pieces of paper to look like a little boat, and take a toothpick, just take a small drop of detergent and put it right in that hole. And there she goes. She's taking off and going around. There she goes. Look at it go. Something's making that boat move. I don't know. I think I can make one of these big ones move. I haven't tried it. Look at that. Take a drop, just a drop of soap. Put it right back in there. Oh, I sunk that one. Sorry, I had an accident. I just crashed the boat. Try another one. Put that one on there. Take just the tiniest drop of detergent and touch it right in that hole. Come on there. Come on, honey, get going. Need a little more soap? You're going to have to experiment. Sweetness. This guy's really going over here. I don't know why. I sunk that one. I'm a disaster as a captain. Yep. Wonder what.
Question for Ian, Jake.
What's the question?
He wants to know, well, it's actually, he wants to know, is it because it's an oil or it's like an oil, the detergent?
Well, it is kind of like an oil in the fact that it's fatty. It's like it's made out of fat. Soap and oil are kind of similar. But what's happening is, when I put the soap in here, and it goes out the back side, it's not the soap that pushes the boat forward. It's the water in front that pulls it forward. And I don't know why this isn't working so well, but we're going to keep trying until we get it to work. You're going to have to experiment like I did. Let's try some of this. There, look at that one go. Boy, he shot across there. That was something.
Oh, okay. That one didn't work very well.
That one didn't work very well, but I just sank that one. Man, I'm murder on these guys. I think you can't be an old man and do that. Anyway, they'll go shooting all around if you do it right. Obviously, I'm not going to do it right. I'll try one more. One more.
Oh, it's bending.
He's bending. There he goes. Well, you try this. It works good. I don't know why it's not working. After a while, if this water gets soapy, you got to dump it out. You get too much soap, it won't work. That's probably what happened. That's why I lost this guy. He just sank to the bottom. But what happens is the soap oozes out the backside, and the surface tension of the water pulls the boat forward. And if you do it just right, don't do it under hot lights like this, these little pieces of paper will be skittling all over the place. Let's do another activity. Do I have another activity? Oh, I do. I do. Let's go over here. We'll do this one. Ooh, this looks awful mean.
Oh, I see something. Thank you, Jake.
Are we leaving?
No. I'm just happy. I see pickles.
You see pickles? I'm telling you. You like pickles?
I do.
Okay, I got a pickle here. And does anybody know where pickles come from? Here you go, Mr.
Cucumbers.
From cucumbers, right. They'll take a cucumber and soak it in vinegar and salt. And it makes the cucumber just shrivel up, pulls all the water out of the cucumber and leaves it salty and vinegary inside. And that salt solution will conduct electricity very, very well. Pickles are a good conductor of electricity a little bit. So we're going to see what will happen if I run 120 volts of electricity through this pickle. I wonder what would happen if I ran 120 volts through a pickle.
Will it cook?
All right, well, we're going to find out. So I'm going to lay this pickle right here in this little tray. And everybody say goodbye, pickle.
Goodbye, pickle.
Bye, pickle.
Bye, pickle, in case we have an accident.
Bye, pickle.
The last poor pickle, I knew him well.
Bye, pickle.
Goodbye, pickle. Are you going to do this at home? No. I'm not going to do this.
Maybe not.
Maybe not. And I've got these two wires right here that if I touch these when the electricity is on, it would really give me a shock. And I've got a safety switch here like that, and this one's on down here. I've got safety switches all over the place, it looks like. So I'm going to plug this in. I've got all sorts of safety switches. And I've got, oh, I've even got these bent there so I can. And I'm going to stick this fork into one side of the pickle. There we go. And I'll stick this fork in the other side. And if this works, we're going to get electricity to travel through the pickle.
Dylan wants to know what happens if it exploded.
Oh,
Bye-bye, Jay.
I better leave then.
Bye, Jay.
Goodbye there. Not very many kids get to see an electric pickle. Is this one fired up? We'll find out. Uh-oh. I just dropped it. I dropped my electric pickle. Here, let me hold this cord. We'll do it this way. Woo, look at it go. Dizzle, dizzle. Can we dim the lights a little bit, maybe? Right here at Hardware Science Workshop, we present the famous electric pickle. Da-da-da!
Hello. We have a question, Jay. Jay wants to know the main systems to have electricity like salt.
Yeah, most pickles will do this if they're dill pickles. I'll turn it off for a second and let it cool down. Most pickles that have that have salt or vinegar in them will light up like this. As a matter of fact, I've done it with eggs, a pickled egg, and you can even do it with hot dogs. You can cook hot dogs. Put a hot dog in here, and this is the way we can cook it. Hey, there it goes. Well, listen, if you like this activity, make sure you keep coming back to Hardware Science and Hands-On Science, all at Midnight Science Club. So we do activities like this all the time. So you'll tell them to check out Midnight Science Club, won't you, Lisa? And,
I sure will. Midnight Science Club.
all right. Hey, Dylan, it's good to see you. Keegan, good to see you. And the man who's tapping on his head, it's good to see you as well.
Thank you, Jay.
All right. Well, see. Hey, Noam, how you doing, Noam? Where are you calling me from, Noam? Where are you at today?
See you again.
He's in Japan.
You're in Japan? All right, man. I'll see you. Talk to you later.
Bye, Jay. Thank you.
Bye.
Everybody else, stay on.
Bye.